Tutorial 8. Properties. Hello, and welcome back to another Mommy's Studio tutorial. In today's tutorial, we will make our first use of properties. Properties enable a high level of flexibility when using capabilities, and even sprites in general. At first glance, they may remind you of global variables, but when used wisely, they enable some rather complex game design. We'll start by loading Mo Baby 1. For those who may not remember, we have a game containing two baby sprites, Normal Baby and Super Baby. The two baby objects share a movable capability, which makes them controllable through the player's keys and subject to different logic when they collide with the cabinet. Super Baby destroys the cabinet, while Normal Baby gets thrown back. Let's take a few seconds to remind us of the gameplay. As you can see, the player controls the babies, with each responding differently when meeting the obstacles. We'll start by going into the movable capability. So far, we've only made use of the top part. It's time to use the large bottom part. This is where properties are added. As you can see, the list is currently empty. Let's add a new property. We are greeted with a few different property types. This most commonly used property type, and the one we will use in today's tutorial, is the numeric property. Let's call it speed. As can be seen on the right, a property has two attributes that interest us. One is the default value, and the second is the description. Let's fill in the description now. Before setting the default value, we need to better understand what we're going to use the property for. Let's take a look at the logic section. We have two key events, each setting the speed of the object either to the left or to the right. Using a number for the speed is nice, but it is very limiting. Let's say we want each baby to have a different speed. Using what we have learned so far, this will require creating a separate capability or object for each, and we would lose the advantage gained by using capabilities in the first place. We'll start by setting the default value to the value seen in the right key down set speed action. We are prompted with two questions. We are told that there are some objects that make use of the property. This refers to the Normal Baby and Super Baby objects in the toolbox. We'll choose Yes. We'll demonstrate the effect of this later. Next, we are told that instances of objects that use this capability already exist, and we are asked if we would like to update their values. Select Yes. Had we declined, the babies that are already placed in the room would have kept their current value of 0. Now, let's modify the expression to make use of our newly created property. Control Space brings up the autocomplete drop-down. As you can see, the property doesn't appear anywhere in the list. Since properties are not global, they are relevant to a specific object instance. This means that they are accessed similarly to some of the built-in properties, such as pos x, pos y, width, and so on. So we'll type self and period. Now we can select our property. Let's do the same thing with the left key press, but this time we keep the minus sign intact. Running the game, you should see that nothing has really changed much. We kept the same speed values, so we shouldn't expect much of a difference. It's time for me to keep my promise and demonstrate how we can easily give different sprites varying speeds, without the need to change the value of actions and without duplicating objects. The initial values of properties can be changed in a number of ways. Changing to a default value, like we did, is one of them, but it doesn't enable precise selection of the objects that should and should not have their values changed. Let's make Super Baby move faster than Normal Baby. For this, we should go to the Super Baby Property screen. As you can see, the list at the bottom contains the speed property. Notice that it appears within a tab called Movable. This indicates that the property does not belong directly to the sprite, but instead was inherited from the movable capability. Selecting the property, we can change the default value. Let's set it to twice the current speed. Again, we are greeted with a dialog asking if we would like to update all instances. And again, we'll select Yes. Unlike when changing the property and the capability, the second dialog is not displayed. This is due to the fact that no other sprites or capabilities are affected by the change. Only the Super Baby object and its instances are affected. Let's run the game again. As you can see, our Super Baby has gained super speed, and it is now twice as fast as the normal baby. This is nice, but what if we wanted to have two sprites of the same kind, but with different speeds? A game with a slowly moving normal baby accompanied by another normal baby that moves even more slowly. To demonstrate how this is done, we'll add another normal baby below our previous one and place a cabinet in front of it. First, we'll run the game, so you'll see I'm not cheating. As you can see, both normal babies move at the exact same speed. Going back to the room designer, I select the top normal baby. Moving over to the bottom right, you can see that the property grid displays various attributes of the sprite. In addition to indicating the sprite's position and dimensions, a movable section appears, where the speed property is displayed with a default value we specified for the object. Let's change it to half the speed. Notice that this time no dialog appeared. This is because the change only affects the current instance and has absolutely no effect on any other object or instance of the game. Running the game, you can now see the difference between our three babies. Super Baby is appropriately moving at super speed. In addition, we have one slow normal baby and an even slower moving normal baby. All of our changes worked. So far, I've only demonstrated giving property values statically. This means the values were given at design time, before the game has run. Values of properties can also be changed while the game is running. To demonstrate this, we'll add another property, this time to the throwable capability. We'll add the property bounce time and give it a default value of 300. Like before, say yes to all dialogues. We'll now replace the start time as action of 300 with our new property. We'll remember the property's name, so we won't use the autocomplete feature and just type it this time. The green check mark to the right means our expression is valid. It is now time to use a new action. Set Numeric Property Action. The action should be placed in the throwable collision event right below the start time action. We'll give it a value of 50, selecting the bounce time property and selecting the relative option. Relative, in this case, means the current value of the property would be increased instead of overwritten. Assuming the current value is 300, calling this action would increase the property to 350 and the following time to 400, then to 450, 500, etc. In effect, this should cause the baby to be thrown back a graded distance each time it hits the obstacle. Let's run the game. Notice the game has the two normal babies collide with the obstacle and get thrown back. You should also see that the collision of one of the babies doesn't affect the distance the other baby is thrown back. You should also see that the collision of one of the babies doesn't affect the distance the other baby is thrown back. This is because, unlike global variables, which are shared by all game objects, properties are specific to a given instance. This means that when the faster baby collides with the obstacle, its bounce time is increased to 250, but the value of the property into slower is still 300. Only upon its own collision, one of the values increased to 250. The properties of the two babies are completely independent. To sum up, the two main advantages of properties are: 1. They are inherited and can be given an initial value. Adding properties to capabilities, sprites, or controllers gives a level of configurability to the game creator who makes use of those objects. And 2, properties are local to an instance. This is their main advantage over global variables. Managing score or the number of lives for a single player can be done using global variables. But when facing a more complex challenge, such as 20 enemies, each with its own life bar, or asteroids moving in variable configurable speeds, properties are the only way to go. We'll save our game under MoBaby 2. This ends the lesson. The next lesson will be an advanced tutorial.